Here's a solution to problem number 2 on the worksheet of rational inequalities, right? So let's see how to do this question. I've seen many solutions for this problem where students will cross multiply and then say, well, 4x squared is greater than or equal to 3x, and then they will bring them together and factor and figure it out, right? At times what students will do is they will cancel 1x from here, right? And they say, well, 4 is greater than or equal to 3 over x, or 4x is greater than 3 and x is greater than equal to 3 over 4, and that is their solution, right? So those are the wrong answers which should not be done in solving rational inequalities. Okay, so all those are wrong answers. Now what is the right way of doing it? Now the right way of doing it is don't cross multiply. So let me just remind you what not to do here, right? First, do not cross multiply. Right? If this was an equation, you could have done that. But when it is inequality, you cannot do it. Okay, that is a major no-no, right? Now the second thing which you should never do is what? That you should not. I should not cancel terms. You understand what I'm trying to say, right? That is x and x, right? You should not do that, correct? Let me be very specific, and let me now give you a wrong solution here first, right? So I could solve this equation as, well, it is 4 over x greater than equals to 3 over x squared. That means I can bring this x squared here, and I say, well, so that means it is 4x squared greater than equals to 3x, and that means I could cancel 1, and so I have x is greater than equals to 3 over 4, right? And that is a huge mistake. So this is not allowed. Correct? This is what you have to learn first before we are doing rational inequalities. This is not an equation, right? Why we don't do this? We don't do this because of simple reason. One reason is that when you factor out, then there is a solution. X equals to x is kind of a solution. So that is not permitted even in equations, right? Because in equation, you could have got one solution, right? Well, here it was a different story because it is a restriction also. First. Second, let us say you write 7 is greater than 5. But if I multiply by negative both sides, what happens? Negative 7, is it greater than negative 5? No, it is not. The sign changes. Sign changes. Now, when you're multiplying by x, you really don't know whether that x was negative or positive. So you're not sure about this sign. And that is the reason why we can't really multiply both sides or divide both sides by x. Okay. So, well, there could be many reasons for that, but this is one of the major one. Okay. Now let's talk about how should we do it, right? The correct way of doing it rather. Okay. So let's do the correct way. The correct way is first write down your restrictions. So what are the restrictions? Here x is in the denominator, therefore x is not equal to 0. It could be anything else, but it is not equal to 0. So that is the first thing. Okay. Second step is, if you're not cross multiplying doing all that, what you need to do is to bring them to one side. So bring all terms to left side. So what do you have? Then your equation will be 4 over x minus 3 over x squared greater than equal to 0. That is your first step. Bring all the terms to one side. Okay, preferably left. Now we can take common denominator. Now for this, the common denominator is x squared. How do you get x squared here? You multiply both by x, right? So this becomes 4x minus 3 greater than equal to 0. So that becomes your rational function which we need to figure out what answers it could give us. Now when you get this kind of a rational function, then you know whenever you sketch this graph, it changes from positive to negative if your graph crosses x-axis, right? And it also changes from positive to negative if there's a vertical asymptote. Because let's say a function is going positive, if there's a vertical asymptote, it could start from negative side. So those are the places where we need to test for positive or negative. Greater than or equal to 0 really means where it is positive, right? That is a part of solution. And if it is negative, it is not a part of solution. That's what we really mean, right? So we are looking for zeros and vertical asymptotes. So in this equation, which are our zeros? So I have taken a very simple example for you, simply because I am trying to teach you concepts. Zeros is when numerator is 0. That means 4x minus 3 is 0. 4x minus 3 will be 0 at x equals to 3 over 4, correct? So that is our 0. And that's the only 0 we have here. How about vertical asymptote? The vertical asymptote is when denominator is 0. In this case, for x equals to 0, we have vertical asymptote, right? So there are these 2 points around which we need to test for positive or negative values, right? So let's draw our lines, kind of breaking our coordinate plane into 3 different regions. Now, x equals to 0 and x equals to 3 over 4 are point of interest. X equals to 0. X equals to 0 is a vertical asymptote. So I'll draw with a big hole here saying this is my vertical asymptote. And x equals to 3 over 4 is a 0, right? So I'll draw a filled in hole saying that, well, this is a 0 and it could be a part of my solution. But this cannot be a part of my solution, right? That is a restriction, correct? That's how it is. Now, so you see these zeros and vertical asymptotes divide our coordinate plane into 3 regions. What are these 3 regions? So this is from minus infinity to 0, right? And this is from 0 to 3 by 4, right? And how about this? This is from 3 by 4 to infinity. These are 3 regions, right? Now, 3 by 4 is kind of 0.75, right? Now let's write down all our factors on the left side. So first factor is, let's write x square first. This is that 0. So I'll use a different ink here. Write down x square as my one part of the function. The other factor is 4x minus 3. So these are my 2 factors, right? X square and this. We will test them in these regions, right? So let's take some test points. So let's take a test point which is less than 0. So it could be minus 1. So this is our test point. And test point between 0 and 0.35 could be 3 over 4, which is 0.75, right? Will be, let's say, minus 0.5, okay? And greater than this could be 1. So we'll take these test points. So the idea here is, let me draw a line here to show my test points, right? Yeah. Now, if I plug in minus 1 in x square, it will become positive. If I plug in minus 0.5, it will become positive. And for 1 also, it will be positive. I'm not really interested in the value, but I'm interested in knowing whether it is negative or positive, correct? Now look here. If I put minus 1 here, this is minus 4, this is negative. If I put negative 0.5, that is half of this becomes negative still. But if I put 1 here, 4 minus 3 is positive, correct? So I get positive. Now if I multiply these 2 things, division is as good as multiplication, right? So if I do this divided by this, an operation, then these 2 are different signs. Since these 2 are different signs, we will get negative here and negative here. But this is positive, so we'll get a positive here. We are looking for something greater than or equal to 0, so our answer is this, which is greater than or equal to 0, right? Now, answer is x belongs to real numbers where x is greater than or equal to 3 by 4, right? That is our answer. Correct. And that's how we solve these equations. Correct?